Okay, so now let's go to question 4, identify the sort. So each column below gives the contents of some list at some step during sorting, and we're asked to match each column with one of these algorithms. And for quicksort, we're told that like some specifics that it uses the topmost element as the pivot, and we're also told to use the recursive, the top-down implementation of merge sort. Okay, so we start out like this and we end up sorted. Of course, this is the correct sorted version. It's nice if they give it to us. So like looking at our options, the easiest one to generally pick out here is like MSD radix sort. Here you sort by the most significant digit, and the most significant digit is really easy to see. Like you want to see that it starts out with ones here, then goes to 2. But here that doesn't really seem to be the case because we have a 1. So then the next natural thing to say is, hey, does it seem like maybe it's the next 2 digits or maybe the next 3 digits? And then if you look here, you'll see, well, no, 162 should be between here. This is an inversion. This is bad. So you can pretty much tell that, like, if this was, like, this can't be MSD radix sort. Then let's look here. So looking here, it doesn't make sense to be 2 digits, so it's probably still on the first digit. And like if you look at it, here you have a group of 1s, here you have a group of 2s, then you have 3, then you have 4, 6, 7, 8, 9. So this looks like it could definitely be MSD radix sort. So, but let's check the others here. We go 1, 4, but then this 1 is not here, so the 1 should be like here. So that tells us it's not C. Then here we start with a 9. It's definitely not it. And then here we start with a 2. So, and then we don't even have 1s at the start. So like it's pretty obvious that B is going to be MSD radix sort. And something you might have noticed, like while going here, is that we had like the maximum element, or like one of the maximum elements here, and the rest of the maximum elements at the end. So this kind of tells you something about this. Like it kind of tells you that this is sort of like a heap structure, like a max heap structure, where you have like the maximum element here, and then you have like the rest of the stuff sorted at the end in like some sort of like separate partition. You can kind of tell like this is where like the heap ends and like sorted stuff begins. So you can kind of get like the intuition that D is like heap sort just from that. Looking at the others, none of them really have like max elements at the bottom other than this one, which we already said is MSD sort. Like one could potentially argue this is like maybe it, but then we've skipped over like some of these, so it really just doesn't work out. I guess like the other radix sorts are always good to look at. So like let's look at LSD radix sort, right? Or we could even look for merge sort, since I guess that's the first one. Let's look at merge sort. So with merge sort, we know that we're using the recursive top-down implementation. So that means we start with an array and then we break it down into like halves, which are all sorted. So what we want to do is we want to see sections of the array which are sorted with respect to themselves. So let's look at A. So here we kind of have sections that are sorted. It doesn't really seem like they're like of uniform size, so it's probably not A. We could look at like C, I guess. With C, it kind of looks more sorted here. Still not of uniform size, but like does it necessarily have to be 3, 4? We all notice that there are 4, so it could be like this. Yeah. And if you look like this is like perfect for merge sort. Especially like since like all of the stuff here come from like this for broken down recursively. And we can see that like everything is being like sorted into its specific merge subsection. Like, so this pretty much tells you that this is going to be merge sort. So, you know, this is going to be merge sort. And then for E, it's either going to be quicksort, LSD. So we need to figure out between A and E. So for LSD sort, that's like the easier one to identify. We can look at the last digit. Here we could see like 2, 7, and then 1. But then what if it's like the next two digits, like 12, 17, 21, 26, 32? This looks good. If it looks like it's partitioning by the last two digits, like it's always constantly increasing between the last two digits. Like, so here this kind of tells us this is probably LSD sort, but we shouldn't rule out A being LSD sort. So if we look here, we see that 642 is decreasing, so that's not it. 76, 74 is also decreasing. And like this is straight up decreasing in any other way, because it's the same. So like that guarantees that this is LSD sort, and by order of elimination, we could say that this is quick sort. Quick sort is generally like the hard one to identify, like, but they do tell you the pivot strategy that's choosing the topmost element. So what you could do is you could choose this as a pivot and just run quick sort and check at each step, are you getting something that's in here? And this actually isn't that many steps into it. But another thing about quicksort is that like at every iteration of quicksort, like this one invariant is that like the pivot will go to the position in the finally sorted array after one pass of quicksort. So 4873 should go into its position in the final array. So if you look here, 4873, it's here. So that tells us that like this one, or this one have to be quicksort. Okay, so I guess as a recap, like something I can do is say like here you want to make sure that like your pivot is in the right position. Pivot in like final position. For MSD sort, you want to look at the most significant digits, but don't forget that you're not just looking for like the first digit with MSD sort. You're not just looking for one, like for sections of ones. It could also be sections of like two digits, because maybe we're in like a secondary recursive call in the MSD algorithm. So look for future calls. And for merge sort, we could look for that you have like these sub arrays that are like sorted, right? Like this idea of like multiple sub sorted arrays, like this is what you want to think about. You want to have like multiple sorted partitions. Finally, for heap sort, you want to see that like the right portion or like the bottom portion is like already sorted. Or I guess like this stuff is like already sorted. Like you see something at the bottom that's already sorted, and you want to see that it's a max heap. Like the max out, other than this, like the max of everything else should be at the first index. That's how you identify that it's a heap sort. And for LSD radix sort, you really just need to like look at the least significant digits. It's like the same as this, but with LSD instead of MSD. Same strategy. So hopefully that helped. Catch you guys in the next one.